EE World, I'm site editor Martin Rowe. Cetecom, an RF test lab based in Silicon Valley, has recently opened a new portion of their lab for automotive hardware in the loop HIL testing, where engineers can bring their boards to the lab, get them tested for RF performance, not just for the physical RF performance, but for the overall performance using hardware in the loop simulation. So the hardware simulator will simulate the environment around the board. And these boards can be, controllers for various things, for infotainment systems and so on. Amber Neves, Director of Sales and Marketing, gave us a tour of this lab the day after the lab was opened in Silicon Valley, and they invited their customers, partners, and so on to that. That was on December 8th, 2022. The recording you're about to see was recorded the following day, and Amber is in the lab, and she will explain what the lab does and what people can do in the lab, and will give us a bit of a demonstration as well. Amber, go ahead. Okay, so Amber, tell me about this lab and about the opening that you had yesterday.
Yeah, so Cetecom has a long history in cellular certification for carrier networks, and as far as T-Mo, AT&T, and Verizon. We were one of the first labs to test CDMA when the first cell phones came out. So we've been testing wireless technologies for over 20 years now. We're located in Silicon Valley. And in the last 4 years, we've seen a trend of the traditional RF engineer pivoting into the automotive industry. So the Bay Area and Silicon Valley is always been a center of technology, and the automotive industry is recognizing that. So a lot of them are putting technical offices here in the Bay Area. And then we are seeing a lot of new EV companies start up. So companies like Rivian and Lucid, Waymo, Tesla, they're all in our backyard, and they're the traditional RF engineer that know us, that come to certify IoT devices and cell phones, and they need help in automotive. So it's the intersection of technology and the automotive industry is where we're at today. So sensing that and feeling that switch happening, Cetecom is now switching our gears. While the lion's share of our business is still cell phone certification for the major carriers, we'll have a lot of automotive offerings. So we can do all the component level certifications, as well as a ton of R&D testing for our local customers here. And it really feels like we've been engaged with these customers for 4 years. And just now we're starting to see designs coming through certification, next generation products being developed. And something else that's interesting is that these EV companies want to design their modules from scratch, right? So they're changing the playbook in the automotive industry in terms of what the traditional form factors look like, what the traditional technologies look like. They don't want to play by the rules of the standard combustion engine design or the chassis layouts or how many antennas are on a car. So we want to partner. We want to be a place for those traditional RF engineers to come. It's actually, I was thinking about it this morning, it's a little bit like an engineering playground. So the Automotive Experience Lab is designed to bring in the cutting edge test solutions from all the major providers. So Rohde & Schwarz, Keysight, and Ritsu. So Anritsu was our first partner to really kick off this initiative. So Anritsu has been working with DSpace on a simulation test bench environment. So testing has been around for a really long time in the automotive industry. That part isn't new. What's new is adding these wireless technologies to that simulation. And it's also introducing simulation testing to these RF engineers that maybe not have been exposed to this. So it's a very different world. And I think it's a unique opportunity to bring simulation test environment into a lab environment. So the idea is to go from a simulation test bench into a chamber, validate those technologies, and then maybe back to the test bench to see how they want to improve that design, make modifications. So we really want to engage with the customers very early on in the design process with hardware in the loop phase. So right when they need to bring in the hardware, they've tested the software in that V shape, if you're familiar with the automotive industry and how they design their components. So they bring in hardware in the loop at a certain stage. And that's where simulation testing comes in. And that's also where the lab can really help that engineer validate frequencies, ensure that there are no radiated spurious emissions, unintended emissions, and things like that. That way, when they get to the certification phase, they pass with flying colors because there's no surprises. So the Automotive Experience Lab, it's a commercially, I'm not charging for it. It's just an environment that engineers can come, bring their component, and then do type of a validation on that component. So we're offering like a 4-hour free session to come in and just play with the technology, as well as get to know us, get to know our engineers, and find out about the other things that we can help them with.
Well, that's a lot, and you left me with a lot of questions.
Awesome.
So I hope I can remember them all. But
Yes.
let's start with you said that engineers are designing modules from scratch. What kind of modules are you referring to?
Okay, so components from scratch. So modules are the radios that Thales and CR Wireless and those guys. So that's one piece of it. The component level. So TCUs, telematics control units, ECUs, electronic control components. So we've learned that there are several of these components within the vehicle. A lot of the engineers are trying to consolidate those components to make the design simpler. So they want to redesign. So they've been using some tier 1 designs, but now they want to change the game a little bit and maybe make it more efficient, make it more streamlined, the form factor, meet their design needs. So those are the engineers that we like to partner with that are working from the ground up.
Okay, I guess when you said components, the automotive business has a slightly different definition of components than I was thinking. And
Okay.
to me, components means the parts that are actually being mounted on the circuit board. You know, the
Okay.
semiconductors, the capacitors, that kind of thing. But we're in a sort of a next level up here. Okay,
Yes.
now that
Yeah.
we're clear about that.
Yes.
So in the past, you're saying that some of these components were not being designed by the same people that are doing them now. So
Right.
they were designed by a different group or a different company, or
Yeah.
the tier
Yeah.
ones would buy a component from from another party and then just integrate it into their vehicle. Now you're saying that they're designing some of these components in-house.
Yes.
I see. Okay. Now, where's the RF come in terms of what RF capabilities are we talking about here?
Well, starting at the top at 5G, right? So they're integrating FR1, not so much an FR2 yet. There's a lot of different technologies when it comes into the automotive. So definitely we're seeing FR1 connectivity on the TCUs, Wi-Fi and Bluetooth, obviously. So, and then some more research that I've done is consumers moving forward will start making purchasing decisions for their automotive vehicle based on comfort, right? So how many bells and whistles does it have? Can I watch Netflix as I drive down the road? Can it make calls for me? Can I talk to Alexa through my car and have it turn on my lights at home on my way home? So the consumer is increasingly looking at those bells and whistles and those comfort factors and making decisions on that. So that's where the wireless connectivity really matters. So we're all connected these days. You know, I've got 2 phones on me now. A lot of people are in that boat, a computer, a laptop, what have you. And we want all those devices to work no matter where we're at. So these cars coming out, you know, they have their own hotspot, they have their own connectivity. as well as the safety aspect and as part of being the wireless technology integration. So radar, LiDAR, those are all services that we offer testing on. And the CV2X, that was a big topic yesterday on how the vehicles communicate with each other, autonomous driving. So a lot of those big topics we discussed yesterday.
Um, since we're recording this, and what did you mean by yesterday? What happened yesterday?
Yes. So yesterday we held an automotive technology day here at Cetecom. We partnered with Anritsu. We flew folks in from all over the world to be at this event just for our Silicon Valley customers. And we showed the latest trends. We talked about the trends. We talked about the latest technologies available to test these trends. We also talked about the current regulatory standards and maybe what might be coming in the future to anticipate those needs. And then we also heard from our partners that have solutions like GT Aero. They make a 5G MIMO OTA chamber. So we for a full vehicle testing, which is a brand new concept and not it's very early in its stage of development, but we're excited to work with them on that. Thales is a module maker, so they've been in the automotive industry for a very long time making their modules. So they spoke to us about how to integrate those modules and having successful designs. As well as our own Dr. Peter Neverman spoke on antenna design and in smart antenna design. So he's got 30 years of experience with Siemens and doing regulatory work with consulting work with Cetecom. So he spoke and also gave us an update on the radar regulatory requirements from the US and Europe. And what those look like now, maybe what we can expect in the future. So, you know, it's a tough part when you're designing electronic components today, but you need to be fail safe for 5 years from now. So we're trying to work with our customers and keeping our finger on the pulse of the regulatory requirements to be that partner for them so they can be confident their designs are going to last for a long time.
The communications that you've been talking about, I know you've talked about 5G and wireless. Is there any wired communication that you do as well? For example, automotive Ethernet? Or do you just do
That
wireless?
is an application. It's not something we've gotten into yet. But we do have a partner, Granite River Labs, who we're also work with on several different projects, and they have solutions for that. But here at Cetecom, we focus on the wireless technologies.
I see.
Yeah.
Now, you seem to say that some of the people coming in are or are not RF engineers,
They are.
they are
Yeah.
generally RF
Yes.
engineers. Okay. So they're familiar with the RF technology more so than the automotive technology.
Right.
How does that work?
Or even, you know, the design integration. So they know the technologies, they know how to test certain frequencies and bands and what those rules are. But integrating that into a larger vehicle, right? So any of those design engineers listening and building an IoT device, anything metal can act like an antenna, right? So there's a lot of design challenges with that. So the car is just a very large cell phone to deal with, right? So cell phone, you have a smaller form factor, you can probably figure out where the radius burst emissions may be happening, or where, you know, your quiet zone isn't quite big enough. But a car is a different animal, because we're seeing these EVs out on the road, and they could have like 4 cell phones in them in terms of the types of computers that are inside those. So the coexistence testing, having, you know, some of these cars have 1,200 antennas on them, all with individual controllers. So there's a lot of crosstalk that can happen. The government, you know, the regulatory bodies are still not even there. We're having conversations about should you certify a car for wireless for a whole vehicle, right? So the industry is ahead of the regulatory requirements in terms of that. So that's where we really are digging in and looking at expanding our capability to support those customers down the road.
Can you tell me a bit about the equipment that's in the lab?
Yeah. So let's see. Behind me here, so this is a HIL setup. So HIL stands for hardware in the loop. So this is a setup. So behind me, you can see the Anritsu. This is the MT8000. And next to that is a D-Space server. So D-Space is a German company. They've been doing simulation software for quite a long time, maybe 30 years. So they've got a long history of doing this type of simulation testing. So this actually application that you see up there, I think you can see the car on the screen. So this is an auto valet parking test scenario. So we've got a board over here. Maybe I can pick this up and take you with me. So this board right here is the TCU component. So that's the component of the car that we're testing right now. And right now we're going to look at the software with that hardware board to see how that technology will perform in an environment, say, that you want your car to go park itself. So the idea would be is that you're out to dinner and you go pull into a parking garage and you don't want to go park your car. So you get out of your car and you tell your car, you go park yourself. And the car can go into the garage. It's got a map of all the parking spaces. It knows where each number is, and it might even know what if it's available or not, but it'll drive through the parking garage and it'll park itself for you. So it's pretty fancy.
I'm in Boston, and I'm trying to imagine Boston drivers in the same environment. The vehicle has its information that there's a parking spot available, and then somebody swoops in from the side and takes it. I can so see this happening. I think this is going to be, as we get to these self-driving vehicles, even and you'll see it even in these small distances, just within a parking garage. Where you have self-driving vehicles and human-driven vehicles in the same space, we in Boston are very much opportunists, and we see something, we go for it.
Yeah.
I got into an accident because somebody did that to me once.
Okay.
But anyway, so the kind of equipment that comes in here now, is this something where you sort of mentioned, I don't know if it's recorded or it was before, but you mentioned something about people coming in and this is sort of a playground.
Yeah.
So do you charge for time in the lab, or how's that work?
Not yet. Right now, it's really an incubator program just to find out what those engineers in Silicon Valley are looking for, what kind of needs they have. We're proposing this first solution, but I also plan on rotating the applications that are available. So down the road, I want to add radar simulation. That's another area that we can test, the CV2X component. So there are a lot of different applications that we have lined up for our customers. We're starting with this hill demo. And I've also got a place that I can, a landing page where I can share with your readers that they could put it in inquiry, let me know what they're working on and where they're at in their design process. And then I'm happy to pull the ecosystem together to really rally around that particular project to help them figure out how to move that forward. So because we are close partners with all of our ecosystem partners, it's easy to grab the right people that know that technology and come in and sort it out. So, and also a little bit about Cetecom. So we've got 7 OTA chambers on site. So that's over the air testing. So all of this wireless technology needs to be tested in a chamber. So we've got a lot of different form factors of chambers, different technologies on the test solution side. We've got FR1 capability in multiple chambers. We've got FR2 capability and what they call a cater chamber. And then we have 2 EMC chambers for the electromagnetic compatibility testing. And it's all under one building. You can walk around the building and go into different chambers and access different things. So it's a really cool place for an engineer to go to one place right down the street from them in Silicon Valley and get their hands on some really, really nice test equipment. So an FR1 system could run, $500,000 to $1 million, depending on how it's configured. So it's not easy to get access to this test equipment. like a high-end vector network analyzer from Anritsu goes from 77 to 90 gig. So those aren't just floating around, that they can get their hands on and start playing with it and using it with their design. So I'm looking to provide those solutions to those customers. And then based on the demand, it'll help me understand where I need to go next. So I've always looked at Cetecom has been, the first in the industry for a lot of different things, and cell phone testing and the FR1 testing. We've been testing FR1 for over 3 years now. So I want to be the first into the next application. And by staying in lockstep with our customers here in the Bay Area, I'm laying the tracks right before they need them. That's kind of how I see myself as, in the old days when they were trying to get the railroad network set up on the Western United States. That's what we're doing here for the EV companies here in California.
Now, the board that you showed us earlier, can you tell us, does that has some RF capabilities? And where I'm going with this is, before our call, I sort of expected this lab to be, more of an RF EMC kind of lab, with the cones on the wall and so on. And I know
Yeah.
you have those.
Yeah.
But in this case, how are you doing the RF that's on, let's say, on that board? Is it just wired directly into the test equipment?
Yeah. So in this instance, yeah, everything is connected with cabling here. And that way we can control the signal and then the traffic, and then working with the simulation software as well.
Okay. So
Yeah, and then you can replicate that when you go into a chamber, and then we do the wireless testing there.
Okay. For our readers who may not know a few things, FR1 refers to the frequencies from roughly 600 megahertz to 6 gigahertz, more or less.
That's right.
FR2 is the millimeter wave, in the US, usually starting at 28 gigahertz and going up to 39, and I think it's 56 or 57. I forget them at the moment. But now within that FR1 range, okay, now which frequencies are being used here? And the reason I ask is because some frequencies are licensed to the carriers. There is a band roughly in the 3.5, 3.6 gigahertz range, varies by country. That's unlicensed. A lot of that's being used for private networks. So in a case of, let's say, a board like this that's behind you, what frequencies does it operate at?
So the most widely used is right sub 6 gig. So it's the C band that all the carriers have chosen to go with. It's the bands that give you the most distance, and you still can transfer the max amount of data as possible. So everybody's really settled on the sub 6 frequency bands. There's still, and which is why you still need carrier certification for these TCUs that are going to operate on the carrier networks. So yeah, that's that, and it's really the network that we're all depending on to have this connectivity piece. So when you're driving down the road, you don't lose, your child's Netflix movie doesn't stop playing in the back, because heaven forbid, that be a problem. So again, it's the comfort and the infotainment capabilities that we're all focused on. Yeah.
Okay, Amber, thank you so much for your time. And I look forward to speaking with you again.
Thank you so much, Martin.